Changes for some companies may be frightening. However, when the company manages to control fear, then it will be a tremendous energy to rise again. And Wika believes that. Being good is not enough. Wika must be great. Wika has represented itself as a state-owned enterprise, SOE, that first entered the foreign market before other contracting companies. This shows that Wika once again not only present, but help to carve a long history of development of Indonesia. Wika continues to try to find a new identity, which is better and more competitive and does not hesitate to reposition itself as a SOE that is ready to compete in the international arena. Wika believes that just being a leading company in the country is not enough. Then construction projects overseas are also rich. In addition, in the context of benchmarking, Wika wants to see and learn how the big companies overseas work. With these efforts, Wika expected then to be able to increase the network as well as strategic partners for strategic work at domestic and overseas. In developing overseas markets, Wika has done selective marketing strategies gradually. Wika enters a strategic in certain countries that are more comparative advantage compared to other countries. Wika focuses on international markets that have been controlled by itself. So far, Wika has reached the construction market in Africa, Southeast Asia, and has entered the Middle East market. In carrying out a project, Wika emphasized the concept of cost, quality, and time. It means we have been trying to make every project that we work on has superior quality, without light efficiency and effectiveness aspects. This is what makes us able to survive in the competition in the construction sector today. These values are unique and provide a strong and consistent platform to encourage every Wika resource in winning the competition, not only in the domestic market, but also in the international market.
Hello? Hello? Jap, jap dulu. Hello? Selamat pagi semua.
Selamat.
Tapi saya tak on kamera lagi. Oh, nak on. Tapi nanti muka aku susah.
Tak, dia memang ada masalah ni. Dia mic, kena pakai mic. Pada semalam lagi.
Apa tu?
Pada hari research.
Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. Ladies and gentlemen, before getting started, let me go over a little bit of housekeeping for the smooth running of the ceremony. Make sure you have a stable internet connection. Kindly mute your microphone, mobile devices, and foreseen noise during the event. And as we are about to begin shortly, please kindly have a seat. Thank you. All participants kindly be reminded that to fill up the registration form given at the parallel section for the certificate purposes. Thank you. A very good morning and a warm welcome to all participants. It is my great pleasure and honor to welcome all of you to International Forum on Integrated Infrastructure Development, Infinid 2021. I am Dr. Dayang Zulaika Amahasbola, will be your MC for today. Together with us today, I would like to welcome Professor Dr. Insinyur Imam Wahyudi, the Chairman of ICCDA for 2021. Dr. Nor Zuraira Heti Muhammad Yunus, the Chairwoman of 12th Geotropica 2021. Dr. Nor Hidayah Abdul Hassan, the Chairwoman of 2nd ICITRA 2021. And I also would like to welcome our generous platinum sponsors, Geotechkindo, 3V Geomatics, GDS Instruments Sdn Bhd, Engineering Seismology and Earthquake Engineering Research is here, Worldwide Ultimate Solutions Sdn Bhd, and Giants Construction Limited. Our benevolent gold sponsors, Anton Par Malaysia Sdn Bhd, Lab Civil Engineering Laboratory, Southern Lab Malaysia Sdn Bhd, PT Wijaya Karya. And our supportive silver sponsors, SureCam Sdn Bhd and PT Pembangunan Perumahan Semarang Demak. Not forgetting our respectable invited speakers from Teto Engineering Sdn Bhd, Senai Desaru Expressway Berhad, and Jurutera Minsar Sdn Bhd. Thank you very much for your kind support towards the success of Infinid 2021. Okay, ladies and gentlemen, to begin the ceremony with the blessing from Allah Subhanahu wa Ta'ala, I would like to invite Associate Professor Insinyur Dr. Ahmad Safwan Abdul Rashid to lead the Doa recitation. Please welcome.
Assalamualaikum warahmatullahi wabarakatuh. Al-Fatihah. A'udzubillahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin arrahmanir rahim maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Ya Allah, Ya Rahim, praise be to God, the Lord of the worlds. Peace and blessing are upon our Prophet Muhammad sallallahu alaihi wasallam and his companions, and for those who followed his example till the judgment day. Allahumma ya Allah, on this blessed morning, in conjunction with the International Forum on Integrated Infrastructure Development, Infinid, we beseech thee and are grateful towards you in favor of all the infinite blessing to us, your humble servant, to live a safe and prosperous life. We seek your blessing for the flawless progress of this event from the beginning till the end. We seek your guidance to steer clear of events that will be detrimental to the progress of this event. Ya Latif, Ya Rahman, please bless us with your tawfiq and hidayah. Please guide us to the greatness, peace, glory, and the prosperity in this world and the hereafter. Make us responsible intellectual, granted us with the valuable knowledge that will be beneficial to mankind in order to gain your mardatillah. Make us righteous servant that follow your commands and neglect the sinful act. Please forgive us for our wrongdoing. Ya Munzilal Barakats. Bestow peace to our beloved country, Malaysia, Indonesia, and the rest of the world. Preserve us from any threat and disaster, neither man-made or natural disaster. And to you, Ya Allah, we ask for security and prosperity upon us, our leaders, and our country. Bestow patience in us in order to face the challenge from you. Please accept our deeds and please reward us accordingly. Allahumma inna na'udzubika minal barasi wal junun wal juzam wa min sayyid asqam. Bismillahilladzi la yaduru ma'asmi syai'un fil ard wala fis sama' wa huwas sami'un alim. Rabbana alaika tawakkalna wa ilaika anabna wa ilaikal masir. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wasallam. Walhamdulillahi rabbil alamin.
Amin amin ya rabbal alamin. Thank you, Associate Professor, Engineer Dr. Ahmad Safwan Abdul Rashid for the dua. May our event today run smoothly and be blessed by Allah Subhanahu wa Ta'ala, inshallah. Okay, ladies and gentlemen, now let's proceed with our main agenda for today. We will have two keynote sessions for today, which will be chaired by Associate Professor Insinyur Dr. Rini Asnida Abdullah and Insinyur Dr. Siti Asma Hassan. So we will start with our first keynote speaker for today, the Honorable Associate Professor Dr. Kamaruddin Ahmad. Please welcome.
Assalamualaikum and a very good morning. Welcome to the second day of Infinid. My name is Rini Asnida and today I'll be the moderator for this morning session. Right, so before we start the keynote speaker, I kindly reminder that the question can be written in the chat box and the selected question will be highlighted and answered by the speaker at the end of the session. Thank you. Dear participant and presenter, I would like to invite our first keynote speaker for today, Associate Professor Dr. Kamaruddin bin Ahmad. It is an honor for me to read through his biodata. Associate Professor Dr. Kamaruddin bin Ahmad obtained his Bachelor of Science in Civil Engineering from West Virginia University in 1985. After working with the industry for 2 years, he joined UTM in 1987 as an assistant lecturer before pursuing his study toward the Master of Science in Engineering at the University of Michigan Ann Arbor in 1990. He obtained his PhD in Civil Engineering from University Technology Malaysia in 2004. His research interests are in the areas of soil improvement and foundation engineering. Lately, he embarked into the area of environmental geotechnics. He was actively involved in the consultation works in the area of geotechnical engineering, particularly those related to site investigation, foundation engineering, and environmental impact assessment, besides being an independent geotechnical checker. He is also the receiver of Thomas Telford Premium for paper published in Ground Improvement ICE UK. Ladies and gentlemen, Dr. Kamaruddin was one of the Geotropica founding committee members back in 1990. He is still the active Geotropica committee member until today. This 12th Geotropica is going to be his final participation in Geotropica series. The 12th Geotropica Organizing Committee would like to extend their appreciation to Dr. Kamaruddin for being an active committee member of the Geotropica series. To honor his continuous contribution to the success of the Geotropica series, as well as his commitment to teaching and learning, research and administration in UTM, the 12th Geotropica Organizing Committee is pleased to call upon Dr. Kamaruddin to deliver his presentation entitled An Assessment of Granitic Residual Soil as Landfill Liner. Please welcome Associate Professor Dr. Kamaruddin bin Ahmad to deliver his keynote speech.
Assalamualaikum warahmatullahi wabarakatuh and hello everyone. I am Kamaruddin Ahmad from the Department of Geotechnics and Transportation, School of Civil Engineering, University Technology Malaysia. To begin with, I would like to congratulate the Infinid 2021 Organizing Committee for their efforts to successfully organize this conference despite this difficult time due to the global COVID-19 pandemic. My sincere gratitude to the committee for giving me the opportunity to share the experience and finding from the work of my research team in the area of environmental geotechnics, in particular with regard to municipal solid waste landfill. The topic that I want to talk about in this presentation is an assessment on granitic residual soil as landfill liners. These are my research team members. First is Dr. Yamusa from Nuhu Bamali Polytechnic, Nigeria. He specializes in geotechnical engineering. Then we have Dr. Nur Aliani Alias from University Technology Malaysia, specialized in groundwater and water engineering. Then Dr. Radwan Saari from University Technology Malaysia, specializes in civil engineering surveying. When we talk about municipal solid waste, these are the items that we discard every day, such as papers, plastic, rugs, food waste, cardboards, etc. Generally, there are three approaches that we can deal with this waste. One is to bury the waste, second, to burn the waste, and third, to recycle the waste. Burning the waste, especially by open burning, without any doubt, will seriously pollute the environment. Such activities must be strictly prohibited. Burning, quote unquote, by incineration, which is considered as a clean technology, may not completely destroy the solid waste. There are certain residues that must be disposed of somewhere else. In addition to that, due to the technology, expertise, as well as the cost of maintenance and operation, are among the factors that prohibit the application of this technology, especially in the developing countries. Recycling, which normally we refer to 3R, reduce, reuse, recycle, even though they are aggressively and actively promoted, will end up where we can no longer practice the 3R, because there are certain ways that we have to deal with. After considering this scenario, we believe that landfilling or landfill facilities are still required or remain relevant. These landfills, which function to store waste, must be designed accordingly to ensure the waste and the associated biological and chemical processes within the waste will not pollute the environment. This slide shows some scenario in a landfill. On the left is a scene of a landfill from a distance, and then we have on the bottom right, that is the leachate treatment facility, and on the top right shows the what we call the drainage system is being installed. This slide shows the typical daily activities in a landfill. On the left, that is the tipping of solid waste. In the middle, that is the spreading. And on the right is the compacting of solid waste in order to reduce to the smallest volume possible and to stabilize the waste so that the lifespan of the landfill facilities can be lengthened. This slide shows the typical cross-section of an engineered landfill. There are several components that must be incorporated and integrated in an engineered landfill, such as the liner system, leachate collection system, gas collection and monitoring system, drainage system, ground monitoring well, and others to ensure the facility functions efficiently and effectively. For this presentation, I will focus on the compacted soil liner, which is one of the components of the liner system. Developing countries such as Malaysia refer to the established criteria or guidelines produced by developed countries such as the US EPA, European countries, and Japan in the design and construction of compacted soil liner. Even though we agree with the established criteria for compacted soil liner, such as the value of permeability cannot be higher than 10 to the minus 9 meter per second, volumetric shrinkage cannot be higher than 4%, and the shear strength must be higher than 200 kPa, there are other soil parameters that must be examined due to the differences in geographical areas, which may result in different soil formation or types that influence the engineering properties of the soil. One of the criteria that our team examined in this study is the effects of gradation of a tropical residual soil namely granitic residual soil on those three aspects, namely permeability, shrinkage, and shear strength. This slide shows the map of Peninsular Malaysia. UTM is situated at the bottom with the pink color, which shows this area is covered by soil derived from igneous rock, namely granite. Soil samples were obtained from within the UTM campus to represent the surrounding area with similar type. With similar type of soil. As generally known, soils are divided into three categories based on particle size, which are fine, which may include clay or silt, and then we have sand and gravel. So based on the natural gradation of the soil sample obtained from the site, then the percentages of the particle size are varied in our study. For example, here we have natural soil sample indicated as L1, okay, which contain 30% fine, 40% sand, and 30% gravel. Then we have reconstituted sample indicated as L2, which consists of 40% fine, 40% sand, and 20% gravel. In addition to that, we have another reconstituted sample noted as L3, which consists of 50% fine, 40% sand, and 10% gravel. Referring to procedures suggested by Daniel and Benson, three types of compaction test shall be performed, namely standard Proctor, modified Proctor, and reduced Proctor. The reduced Proctor should be conducted using standard Proctor hammer, but the number of blows is reduced to 15 blows per layer for 3 layers. For this study, however, we only managed to perform the standard Proctor test. In the near future,
Right. Okay, sorry. We have a slight technical difficulties. I hope you can still bear with us while we are trying to fix this thing. At the meantime, you can put any question in the chat box if you have any. Okay. All right. Okay. Seems that we have a question in the chat box. Is possible? Dr. Kamarudin is with us now. Right. So let me read through the first question right from Azima. Okay. Doctor, may I ask, considering the cost of land for the development of landfill facilities is increasing, especially in the big cities, is there any limit in terms of height of waste so that the facilities can accommodate more waste? Thank you.
Thank you for the question. In terms of this maximum height of the waste, so far I don't see any limitation, but it depends actually on the design of the facilities. Okay, so there are certain aspects that we have to consider in the design, such as the foundation soil. We have to make sure that the foundation soil is strong enough to carry or to sustain the load from the waste. And then we have to consider the strength of the liner system. Okay? Similarly, just like the foundation soil, it must be strong enough to carry the load from the waste. And then we have other element that we have to consider in terms of strength, that is the piping system. I'm referring to the leachate collection pipe. We have to make sure that the material of the pipe must be, again, strong enough to receive the stress from the waste. So all those things are considered are related to strength. As long as the material are strong enough to carry the load, we can dump our waste as high as we want, right? In addition to that, we have to make sure that the slope of the waste must be designed accordingly in order to prevent any slope of failure. So, in conclusion, I would say that the limit or the maximum height of the waste should be considered by considering the strength of the foundation, the strength of the liner system, the strength of the piping system, as well as the slope of the waste. As long as those are designed accordingly, then we can determine the maximum height. I hope I answer your question.
Thank you so much, Dr. K. Right, so it seems that our technical problem is solved, right? So we're back to the keynote speaker. Thank you.
Slide, we can see that the camera and then the soil sample in the middle, and behind the sample, actually, those are the two sheets of mirror. So by having those two sheets of mirror, we can observe around the soil sample. This digital image analysis will carry out based on the photogrammetry method. Okay, let's go to the analysis and the key findings of this study. On the right-hand side, those are the plots of the soil gradation. The blue color represent the natural soil containing 30% fines, 40% sand, and 30% gravel. The red curve represent the first reconstituted sample, L2, which contain 40% fine, 40% sand, and 40% gravel. The green curve represent the second reconstituted sample, L3, which consists of 50% fines, 40% sand, and 10% gravel. On the left, we can see the table. So the values tabulated in the table was obtained based on the soil properties of the natural soil L1. The table on the left shows the recommended values for soils to be used as a standalone material for the construction of compacted soil liner. Take note that these values were obtained from soil in temperate regions such as US and European countries, not tropical regions. So for comparison, on the right-hand side, those are the values obtained from the soil sample that we use in our study. This slide shows the compaction curves of the natural soil, reconstituted soil. The blue curve shows the compaction curve of the natural soil. The red curve shows the first reconstituted sample containing 40% fine, 40% sand, and 20% gravel, whereas the green curve shows the compaction curve of the second reconstituted sample, L3, which consists of 50% fine, 40% sand, and 10% gravel. Take note that the compaction tests were performed by varying the moisture content, but with respect to the optimum moisture content, the moisture contents were varied 2% on the dry side and 4% on the dry side. Similarly, 2% on the wet side and 4% on the wet side. So the top line represents the zero air void line. Okay, this slide shows the result that we obtained from permeability test. Even though we have a lot of plots here, let's focus on the top left plots. Okay? On the top left plots, we can see that the blue curve represent the natural soil, which contain 30% fine, 40% sand, and 30% gravel. The red line or the red curve represent the first reconstituted sample containing 40% fine, 40% sand, and 20% gravel. The green curve, meanwhile, represent the second reconstituted sample, L3, with 50% fine, 40% sand, and 10% gravel. So based on these plots, we could see that only sample L3, which consists of 50% fine, 40% sand, and 10% gravel, satisfy the permeability requirement, which is 10 to the minus 9 meter per second. Sample 1, L1, and sample L2 fail in this criteria. This slide shows the result from the shrinkage and swelling test. If you can see that here, all the soil or the soil of all gradation experience shrinkage 4% and less on the dry side. On the wet side, the shrinkage achieve more than 4% for all soil gradation. Okay, for this slide, let's focus on the top left plot. Okay, again, the blue curve represents the L1 or natural soil. The red curve represents the samples, the soil sample containing 40% fines, and the green curve again represents the second reconstituted sample containing 50% fines. Based on the 4% shrinkage as the cutoff value, then we could observe that for all soil gradation on the optimum moisture content as well as on the dry side fulfill the requirement in terms of volumetric shrinkage. On this slide, let's focus on the right-hand side curves, which shows the result from the unconfined compression strength test. Okay. By taking 200 kPa as the cutoff point, we could see that on the wet side, soil at all gradation fail to achieve the required strength, whereas soil compacted on the dry side for all soil gradation satisfy the requirement in terms of shear strength. Okay, this slide shows the acceptable zones in terms of hydraulic conductivity, that's on the top left. And then we have the acceptable zone in terms of volumetric shrinkage on the top right. And then we have acceptable zone in terms of shear strength at the bottom left. So the shaded area for each diagram shows the acceptable zone. Superimposing these three plots, we each end up with the acceptable zone, which is shown by the shaded area with squares. So those are the result from the superimposing of those three plots. The overall acceptance zone represent the acceptable requirement, represent the accepted requirements in terms of hydraulic conductivity, shear strength, and volumetric shrinkage. Take note that based on the previous slides, only soil sample containing 50% fines fulfill all the requirement. This slide shows the result from the digital image analysis. On the left-hand side, represent sample L1, that is the natural soil. In the middle, represent the first reconstituted sample L2, and on the right, represents sample number 3, that is L3, which is the second reconstituted sample. So from this slide, we could see that soil sample containing 30% fines shows the longest migration of leachate as compared to soil sample containing 50% fines, which shows the shortest migration distance. If we can observe the value for the soil containing 30% fines, the maximum migration is about 10 mm. For the first reconstituted sample, the migration is about 5 mm or 6 mm, and the second reconstituted sample containing 50% fines, the migration is less than 5%. Those observations were made for 1 month. Allow me to summarize the result or the finding from our study. So the first, the hydraulic conductivity decreased with increasing molding water content regardless of the soil gradation. In this case, samples with 50% fine content fulfill the regulatory hydraulic conductivity value of 10 to the minus 9 meter per second. The volumetric shrinkage, the unconfined compressive strength increased with decrease in molding moisture content for all gradation. Soil of all gradations recorded strength greater than 200 kPa on the dry side. And then samples with 50% fine content compacted based on British Light, or in other words, standard Proctor, prepared with molding moisture content or water content of 24 to 28%, fulfill the requirement in terms of hydraulic conductivity, volumetric shrinkage, and shear strength criteria. As a conclusion, based on the British Standard Light Compactive Effort, or standard Proctor, laterite soil of granitic origin containing 50% fines with molding moisture content between 24 to 28% fulfill the compacted soil liner criteria in terms of hydraulic conductivity, volumetric shrinkage, and shear strength. So take note that whenever we use granitic residual soil as a standalone material in the construction of compacted soil liner, we have to make sure the fine contents must be greater than 50%, as opposed to the values as established in the guidelines by the developed countries, where the fine content should be more than 30%. Before I end my presentation, on behalf of my research team, I would like to extend my sincere appreciation to the staff of Soil Laboratory, School of Civil Engineering, University Technology Malaysia, Geotechnical Research Group, School of Civil Engineering, University Technology Malaysia, Nuhu Bamali Polytechnic Nigeria, for their assistance in carrying out this research. Thank you.
Okay, thank you so much, Associate Professor Dr. Kamarudin bin Ahmad, for the insightful speech. Right, so I will read through a question from the chat box. Right, so I pick up one question from Rinda Karlinasari. Okay, so the question, Doctor, since residual soil is used, is there any criteria for shrinkage limit? As you know, if high temperature, dry season may make a crack at the soil. Right.
Okay, thank you for the question, Ms. Rinda, I guess, right? In terms of the shrinkage limit, from our research, actually based on the established criteria, which is referred to the value of 4% shrinkage, that is the maximum. So based on our study, which we conduct on the residual soil, 4% shrinkage, we observed that the soil sample was still intact. In that case, I would prefer that we limit the shrinkage limit according to the established criteria 4%. Maybe we can study further in order to to determine what is the maximum shrinkage limit that is allowed by a residual soil. I hope we have time and manpower to do the research in terms of the shrinkage limit for the residual soil. Okay, so that we may refer to the value as the criteria to be referred to as the for the development of compacted soil liner in tropical area using residual soil. I hope I answer your question.
All right, thank you, Dr. K, and hope that it will answer Ms. Rinda's question. Right, so I think I may take another last question from Azima. The question is that I visited a landfill facility and I observed black liquid coming out from the waste and flowing down along the face of the side slopes of the waste. Were there any problem with the design of the facility? Any comment on the suggestion to solve the problem? Okay, okay.
Leachate or liquid flowing along the.
Please unmute yourself, Dr. K.
Okay, when you observe liquid or leachate flowing out. Can you hear me now?
Yes, yes.
Okay, if you observe liquid or leachate flowing along the face or the slope of the waste, maybe that is due to the accumulation of leachate, especially when we have high moisture content in the waste, especially in the tropical area where we have received a lot of rain. So the extra generation of leachate will accumulate. The generation of the leachate maybe overcome the rate of the leachate flowing down. That's why when the leachate accumulate, it start to build up, and then maybe because of the arrangement of the waste, because the waste were not arranged vertically, which will allow the leachate to flow downward. Because the waste were arranged, the waste, the arrangement of the waste, maybe some are vertical, horizontal. So the accumulation of the leachate will not be able to flow downward very fast, and then it start to divert laterally. That's why we can see leachate flowing out from the surface of the slope of the waste. Okay, in order to overcome that problem, I will not comment on the design because we don't know how they design the landfill facility. But maybe for the short-term measure or short-term settlement in this to solve the problem, I would suggest that perimeter drain should be provided along the perimeter of the waste, so that the leachate that flow out from the waste can be collected and can be drained to the leachate treatment system. Okay, so I hope that will answer the question, right? Because of the random arrangement of the waste prevent the downward flow of the leachate, and that it causes the leachate to flow laterally. I hope I answered the question.
Right. Okay, thank you so much, Dr. Kamarudin, for the Q&A session. Okay, actually we have more question in the chat box, but I hope you can, scan the QR code. Okay, if you have more further questions, and email to Dr. Kamarudin. Right. And I also forgot to mention that you actually can follow Dr. Kamarudin in the YouTube channel. Just go to YouTube and Kamarudin Ahmad PhD. Then you will find a lot of very interesting lecture on the geotechnical. Thank you so much. So I'm back to you, Dr. Dayal.
Thank you very much, Associate Professor Engineer Dr. Rini Asnida and Associate Professor Dr. Kamarudin Ahmad. Now, let's proceed our event for today with our second speaker, Dr. Haryati Yaakob. The session will be moderated by Engineer Dr. Siti Asma Hassan. Please welcome.
Hello everyone and welcome to today's session. I am Siti Asma Hassan, moderator of this session. Ladies and gentlemen, before we start with the keynote speaker 4, I would like to announce that questions for Dr. Haryati can be written at the chat box. Now I would like to introduce our keynote speaker, Dr. Haryati Yaakob, who will talk about asphalt pavement resilience adaptation to changes. Dr. Haryati is a senior lecturer in the School of Civil Engineering, University Technology, Malaysia. She gained her civil engineering degree from University Technology, Malaysia in 2001, Master of Science in Highway Management and Engineering from the University of Birmingham, UK in 2002, and Doctor of Philosophy from the University of Ulster, UK in 2007. Dr. Haryati leads several research projects and innovations related to highway materials, road design, and pavement condition assessment. She has been working closely with highway agencies and pavement stakeholders, such as Malaysian Highway Authority, Public Work Department, and Leaderscope Consultant Sendirian Berhad. She is currently serving as an evaluator in Malaysia Board of Technologies and plays a significant role in Pavement Association. Please welcome our special guest, Dr. Haryati Yaakob, to deliver her keynote speech.
Assalamualaikum and a very good morning, ladies and gentlemen. I'm Haryati Yaakob from University Technology Malaysia, and today I'll be presenting about asphalt pavement resilience adaptation to changes. Evidence from previous studies has shown that the climate is changing. For example, global surface temperature has increased 0.85 degrees Celsius between 1880 and 2012, and the rate of change has become more rapid in the most recent decades. Meanwhile, the sea level has been rising globally, and extreme weather events, for example, floods, hurricanes, and heat waves have become more frequent in many regions. Today, I'll be presenting on some of the conceptual sequence of impacts of climate change on the pavement system, followed by the current and ongoing research, the adaptation and mitigation. Ladies and gentlemen, now, as you can see, here is the mean daily temperature in one of the cities in Malaysia from year 1960 to 2018. And it shows here the range of temperature fluctuation was between 26 degrees Celsius to 28.7 degrees Celsius. The magnitude of increase in the annual average of mean daily temperature as indicated by a gradient of the linear trend line. The temperature spikes in 1997, 1998, and 2015, 2016 were due to strong El Nino, with the 2015-2016 event being one of the strongest one. This graph shows the average monthly rainfall in Malacca, where it was generally below 500 millimeter, except between 2009 and mid-2010, where the monthly rainfall peaked in the mid of 2010. Higher interannual precipitation, for instance in 2009 and 2010, could be affected by the La Nina episodes, during which sea surface temperature in the east central equatorial Pacific dropped below the average. The study also revealed an increase of days with more than 20 millimeter rainfall by 1.5 per decade in the same period. The extreme weather events in Malaysia are characterized by days of high temperature, high rainfall, dry spell, thunderstorms, and strong winds. The past decades have seen increasing occurrence of extreme weather events. The worst floods were recorded in the southern Peninsula Malaysia during the 2006-2007 monsoon. Days with extreme rainfall events have been on the rise since 1980s. This also parallel to the global increment of extreme weather, especially floods and storms. So, how does the situation I mentioned earlier could affect our pavement? Asphalt pavements are climate-sensitive infrastructure, where climate can impact their deterioration rate, subsequent maintenance, and life cycle cost. In regions where the negative changes will occur, the additional costs may be incurred by road authorities to address this. If nothing is done, costs will be borne by the users in terms of the losses of fuel consumption, safety, and time. On a national level, this means the sum of costs incurred due to the climate change may become significant, and additional budgets will be needed for climate adaptation and mitigation in the future. So, before we go further, let's define what is pavement performance. Pavement performance can be defined as the ability of a pavement to satisfactorily serve traffic over time. It further defines the serviceability of a pavement as the ability to serve the traffic for which it was designed. The factors that are found affecting the performance of the pavements are presented in this figure, which are the climate, numbers of traffic, and the material properties. And now, let's have a look on how does climate affects the pavement performance. In general, climate change can have a direct impact on an environmental condition and therefore change the pavement performance. From the literature, the most common climate stresses include temperature, precipitation, groundwater, cloud cover, and wind speed. Typically, pavement climate performance is most influenced by temperature and moisture, and the long-term impacts from the stresses can be significant. And as we know, an asphalt pavement is affected greatly by the natural environment, including constantly changing external environmental factors such as solar radiation, external temperature, airflow, and rainfall. The three forms of heat and energy exchange that occur in the structure of an asphalt pavement comprise radiation, convection, and conduction. Some of the solar radiation and sky radiations are reflected by the road surface, and the rest is absorbed and transformed into heat energy. This part of the heat energy is superimposed on the external temperature, thereby resulting in a high surface temperature which generates heat conduction mainly along the thickness of the road surface. And this could be the significant contributor to the urban heat island and global warming. Ladies and gentlemen, it has widely known that bituminous and asphalt mixtures are temperature-sensitive materials, and therefore their strength and modulus vary with the change in the temperature. Increases in temperature can reduce the stiffness of asphalt materials, which can limit the stress-strain response of the pavement and reduce the ability of a pavement structure to spread loads. In addition, even if the change in the stiffness of these materials is not significant over the length of a single day, changes in stress and strain response and load spreading ability can exhibit their effects in the long term and may accelerate load-related deterioration. Furthermore, the ability of asphalt materials to resist permanent deformation reduces as temperature increases. Increases in the temperature ranges due to the climate change also can increase thermal stresses in asphalt layers, and more thermal cracking can be expected. In addition, higher temperature can lead to faster aging of asphalt mixture, and pavement can become more prone to crack due to brittleness. Development of pavement distress will change over time due to the impact of climate, with required changes being within the range of the current material properties. Then, a critical first step is to identify and monitor the key pavement performance parameters and search for trends that develop over longer periods. It was highlighted by previous researchers that these are the key pavement indicators that need to be monitored for climate change impacts for asphalt and concrete pavements. Now, we move to precipitation. Have a look on this list of major floods in Malaysia from 2006 to 2018. However, this is not the whole list. I've just picked some of the worst extreme flood that had happened. So, ladies and gentlemen, how does this extreme rainfall and flood as part of the precipitation will affect the pavement performance? Yes, okay. Precipitation and groundwater can impact pavements by changing the moisture levels in pavements. In practice, moisture can enter and exit the pavements in different ways. Surface runoff can enter a pavement structure from its sides and through cracks and potholes. Moisture content in the unbound granular layers and subgrade can be significantly affected by the groundwater level in regions where the existing groundwater level is high. Due to flooding or heavy rain, the pavement subgrade or even unbound layers may be submerged, resulting in significant moisture level. With an increase in the degree of saturation, the resilient modulus of unbound and subgrade materials can decrease significantly. The shear strength of the unbound and subgrade material may reduce significantly at high level of saturation, which can cause permanent deformation to accumulate rapidly and under extreme circumstances, which will lead to collapse of the material. Moreover, moisture can also impact asphalt concrete materials. Stripping at the asphalt surface can be caused by various factors, such as poor materials, construction, environmental factors, or combinations of one or more of these factors. It was found that saturation in asphalt layers can accelerate stripping. This is probably because of excessive moisture in the asphalt layer allows pore pressure to develop under trafficking, which can disrupt the aggregate bitumen adhesion. In regions where precipitations increase, stripping may become more frequent, especially when drainage is inadequate. Now I'm showing some of the pictures during the major flood that happened, I think, January 2015 in Kelantan and Pahang. As you can see, when there's a flood, the failure mainly happened on the foundation, where at a certain point of saturation, the unbound materials would just collapse and bring together the asphalt layer on the top. The asphalt layer, as this picture has shown you, the asphalt layer has been peeled off from the base just like a jigsaw puzzle. So all these failures here were due to the soil movement caused by water. Ladies and gentlemen, now there was a study looking at the effect of annual temperature and annual precipitations towards pavement performance. And this study using mechanistic empirical design approach. This study was conducted in the United States and has been divided into 4 different regions that are freeze-dry, no freeze-dry, freeze-wet, and no freeze-wet, with respected temperature and precipitation as shown in the table. Generally, the mean annual temperature has significant effects on all of the flexible pavement distress. This was statistically confirmed by the results with a p-value of less than 0.05. However, the mean annual temperature has not resulted in significant impact of the International Roughness Index, IRI, of a pavement surface, which is based on a p-value approximately 0.415. The longitudinal cracking, which is the top-down cracking of a flexible pavement, is significantly affected by the mean annual temperature and precipitation. It was found that a higher mean annual temperature results in higher longitudinal cracking. And this longitudinal cracking, or known as top-down cracking, is predicted to be severely reoccurring in the wet climate region. The top-down fatigue cracking is the critical in the wet region because it allows water to infiltrate the underneath pavement layers that may cause failure to the pavement structure. It was found also that a higher mean annual temperature results in higher alligator cracking. On the other hand, the alligator cracking, which is the bottom-up cracking, is more prominent at the high temperature climate region and also high precipitation region, where these cracks starts at the bottom pavement layers and progress to the pavement surface due to the asphalt layers that deflects under wheel loads. Obviously, the alligator cracking is predicted to occur in the no-freeze wet climate. This is due to the conditions of asphalt that is highly aged, which is the result of the exposure to high temperature and the presence of moisture that weaken the base of the sub-base layer of the pavement. However, transverse cracking, or known here as thermal cracking, is more pronounced for the pavement placed under the low temperature climate region. The thermal cracking, also known as the low temperature cracking, commonly occurs due to the sudden drop in temperature, which causes extreme thermal contraction and fracture of the asphalt layer. And finally, the highest predicted permanent deformation of both asphalt layer and total pavement would occur in the hot climate region. In the case of asphalt layer rutting, the viscous properties of asphalt binders that is used as a bonding agent in flexible pavement allows the material to shift slowly or deform permanently under the influence of continual stresses. Ladies and gentlemen, it should be noted that pavements are not only affected by climate variations but also contribute to them. The reasons are twofold. How does pavement affect the global temperature? Pavement structure covers a significant percentage of city skin surface, which about 29 to 45% of the urban land. Many studies have shown that the effect of heating mechanism of the pavement plays an important role in the formations of urban heat island, UHI. The UHI is identified as a heating process in the urban areas that could create a different temperature between urban and its surrounding rural areas, both during daytime and at night. Pavement and other building structures occupy a significant percentage of the total land cover in the developed city areas. Most of these urban structures are made from low albedo or surface reflectivity materials, which can absorb and store huge amount of heat from the solar radiation, especially during hot and sunny day, and then release it back to the surrounding environment at night time, which later can lead to this UHI and global warming. A conventional or typical pavement is commonly made of dark color asphalt, which represent a low albedo. It absorbs huge amount of heat emitted from the solar radiation during the daytime and re-radiate the heat during the nocturnal period. When the incoming solar radiation hits the asphalt surface during daytime, the asphalt pavement has the possibility to experience a high surface temperature range from 48 to 67 degrees Celsius. Compared to light colored surfaces, most color radiation reflected from lighter colored surfaces passes out into the space. As mentioned in previous slide, Typically, a lighter color is more reflective than a darker color. Those newly constructed concrete pavement have a higher albedo than newly constructed asphalt pavements. However, due to weathering and the accumulations of dirt, the albedo of conventional asphalt and concrete tend to change over time. Asphalt consists largely of petroleum derivatives as a binder mixed with sand or stone aggregate. Asphalt tends to lighten as the binder oxidizes and more aggregates is exposed through wear. And therefore, asphalt becomes lighter and it will increase the albedo. Concrete also uses sand and stone aggregate, but in contrast to asphalt, it uses Portland cement as a binder. Vehicle traffic generally dirty the cement, causing it to darken over time and reduce the albedo. Pavement albedo is also affected by material properties, including the type of aggregate used. It is also found that the transportation sector generates the largest share of the greenhouse gas emission. From a life cycle analysis, it was determined that the construction of hot mix asphalt HMA layers generates a carbon footprint of 65.8 kg of carbon dioxide per kilometer of road. In addition, it was evident that HMA production generates the greatest environmental impact among the considered life cycle cost analysis production and construction stages, with the GHG contributions of 38 to 39% from bitumen only. Therefore, a special attention to HMA production is required in order to minimize the GHG emissions. Ladies and gentlemen, and now we move on to look on the adaptation and mitigation on how we can suit our asphalt pavement and transportation system into the climate change. When you're dealing with the climate change in higher average temperature, things that can be done is by raising high temperature asphalt binder grade. Yes, Malaysia had changed from bitumen penetration 80-100 to penetration 60-70 in year 2017. Then increasing the use of binder polymerization and improve the aggregate structure in asphalt mixture. Apart from that, increase the use of rut and crack resistance designs, including thin surfaces, and also increases the use of binders that age more slowly and expand the use of asphalt pavement preservation techniques to address the binder aging. So there are lots of research that has been done and still ongoing in helping these adaptations of asphalt material deals with the climate change. Ladies and gentlemen, in Malaysia, one of the efforts being explored and widely used as part of adaptations of asphalt mixture is the usage of Kaplam modified asphalt, CMA. Malaysian Rubber Board, MRB, and Public Works Department have been involved in a joint study to determine the effectiveness of using this Kaplam modified asphalt for road construction or resurfacing works. In fact, last year, in 2020, the Cabinet has agreed to expand the use of Kaplam modified bitumen for the construction and maintenance of roads registered under Malaysian Road Information System, MARIS. Apart from helping in the natural rubber price, CMA technology has proven to improve the resilience and durability of roads in terms of resistance to cracking of the road surface. Kaplam has also been found to increase the viscosity of the asphalt mixture, thus rendering it more resistant to higher temperature. The Kaplam has been widely used as part of road maintenance in Malaysia. Cost of road construction using CMA is about 15 to 20% higher compared to the conventional method. However, in the long run, CMA roads can prove to be more economical as they will last longer and cheaper to maintain as well. Right, apart from CMA, another type mix that widely used in maintenance in federal, state road and expressway is super fiber mix, SFM. This mix has been added with a synthetic fiber, polyethylene fibers, and aramid. Aramid fibers will not melt in the asphalt mix and are known for their strength and durability in both high and low temperature. By adding these fibers, asphalt mix was found to have better durability with a longer service and reducing the overall life cycle cost. As you can see here, the yellow color, okay, the Arabic fibers, and it provides the strength and durability in both high and low temperature. Ladies and gentlemen, as part of a mitigation, many authorities and agencies around the world have come out with their sustainability rating tools in measuring the level of sustainability in development. While in Malaysia, there are 2 rating tools specifically established for the development of road and infrastructure, which are Malaysian Green Highway Index, MyGHI, and Penerapan Hijau JKR for road, or known as PHJKR. MyGHI is a rating tool to assess the sustainability of a highway, whereas PHJKR is a rating tool to assess non-highway road, but only limited to federal road project only. Malaysian Green Highway Index, or MyGHI assessment, was developed by Malaysian Highway Authorities or Lembaga Lebuh Raya Malaysia, where this assessment consists of 5 categories, which are sustainable design and construction activities, energy efficiencies, environmental and water management, material technology, and social and safety, with 27 relevant main criteria. This rating tool was studied and developed based on established rating tool system available around the globe. And this is the example of scorecard for MyGHI, where the 5 categories has been divided into subcategories in more details. Based on the total score, the road projects will be given a certification level from the highest one, which is the platinum, gold, silver, and certified. Okay, this is the list of rating system for road development, which originated from US. These US-based rating tools are dedicated to assess roads and highways development. And the one highlighted in the red box here are the MyGHI and PHJKR, which covers the planning stage, design stage, construction stage only. However, MyGHI, it does cover the operational and maintenance stage. MyGHI also is in development stage of carbon dioxide assessments in their respective operation and maintenance criteria. Apart from having green rating tools, other mitigation that has been widely used and practiced as one of the common techniques of road maintenance and rehabilitation in Malaysia is coal-in-place recycling, CIPR. For the road to perform functionally and structurally, they add about 4% cement to the old asphalt pavement, and with this there will be a significant cost saving and minimum use of energy and material. When compared to other traditional conventional rehabilitation such as mill and pave, CIPR emits fewer greenhouse gas emissions by using less energy and virgin materials. It was found that when the entire process is considered, the CIPR process emits an equivalent of 5 to 20 kg of carbon dioxide, whereas for hot mix asphalt emits equivalent of 45 to 50 kg of carbon dioxide per ton of material laid, even when the hot mix process uses recycled asphalt. Another mitigation aspect that can be considered in future here is a cool pavement. The term of cool pavement has mainly referred to the reflective pavements that help lower surface temperature and reduce the amount of heat absorbed into the pavement. The first cool pavement option that we can have here is the conventional asphalt pavement, which consists of asphalt binder mixed with the aggregates. It can be modified with high albedo materials like using light color aggregates, colored asphalt by pigments or sealant, or using triresin in place of asphalt. Apart from that, we can use conventional concrete pavement. Conventional concrete pavement generally has a higher reflectance than the asphalt pavements. It can be modified to increase the reflectance by using the white cement or cement blended with light color of slag. Then we do have non-vegetated permeable pavements which contain voids and are designed to allow water to drain through the surface into the sublayers and ground below. The example of non-vegetated permeable pavements are porous asphalt, pervious concrete, open graded friction course, and porous concrete block paver. Another option, cool pavement, is vegetated permeable pavement, such as grass paver, concrete grid pavers that allow grass or other vegetations to grow in the interstices. These materials are most often used in areas where lower traffic volumes would minimize the damage to the vegetation, such as parking lots and trails. Chip seals are also considered as cool pavement option, which are often used to resurface low-volume asphalt roads. And finally, we do have microsurfacing. Microsurfacing is a thin sealing layer used for road maintenance. In microsurfacing, light color materials can be used to increase the solar reflectance of asphalt. Researchers recently applied light color microsurfacing material in the consisted of cement, sand, other fillers, and liquid blend of emulsified polymer resin, and found the solar reflectant to be comparable to that of a new concrete. Ladies and gentlemen, as a conclusion, asphalt pavement design and maintenance needs to consider changes in high temperature to adapt to future climate. Asphalt binder upgrading to adapt to greater temperatures can be applicable, but its cost effectiveness need to be further investigated and justified. Pavement maintenance will be triggered earlier on the significant road networks due to the climate change. Road agencies need to be aware of this and be prepared for the much earlier arrival of the maintenance budget. The highway transportation sector is a significant source of total greenhouse gas emissions, and highway life cycle cost analysis can be applied to plan this GHG emissions reduction and help mitigate climate change. In addition, climate resilient and sustainability pavements design and management are multi-objective. They will not only need to adapt to the impact of climate change, but must also play a role in reducing the GHG emissions. Future research in these areas is highly needed. With that, I end my presentation. Stay safe, stay healthy. Thank you very much.
Thank you to Dr. Haryati Yaakob for her insightful thoughts on the adaptation of asphalt pavement in tackling the climate change issue. Now, I will read two questions from the chat box. Question number 1 from Pak Heri Awan Susanto. How we can design the pavement to against the climate change toward the pavement resilient? Do you think we need to change our parameter of mix design? And then the second question from Pak Imam Wahyudi. How can we build the drainage system along of road to decrease pavement crack cause of climate change?
Okay, Assalamualaikum warahmatullahi wabarakatuh. Thank you very much, Dr. Siti Asma. Right, the first question, which is about the design, right? The design, how do we deal with the design when it comes to this climate change? I would say that, as I talked earlier, Malaysia has taken few steps forward in adapting this climate change, where we start to move, using from bitumen penetration 80-100 to a harder one, which is bitumen penetration grade 60-70. Okay, and then secondly, in year 2015, Public Work Department has developed a new structural design, which is based on mechanistic empirical pavement design guide model. Okay, we know we call it as MEPDG model. So in this model, we do take consideration the climate data sets, the climate data set as an input, and then we simulate, the pavement performance, pavement deteriorations over a period of time. Okay, so I would say that we actually taking some few elements of the parameters such as the temperature, precipitations embedded into this current design we've been using. Okay. Then the second question is about the drainage, right? Okay. I think when we talk about drainage, it relates to flood. Okay, and then when we have heavy rainfall, this is the common, I think the most common natural disaster that happened in Malaysia. We face this flood problem every year. Okay, then when we have flood, that will accelerate the deteriorations of our pavement. Okay, because it's exposed to the extreme moisture. Okay. So how do we actually handle this? Is I would say apart from focusing on the ground improvement, soil stabilization, or apart from focusing on this what you call the resistance of moisture susceptibility of asphalt mixtures, I think the most important thing, as you said just now, is actually the drainage system. Okay, so I would say that the drainage systems that we have now need to be designed, need to be properly designed, need to be properly maintained accordingly, properly, together with the climate data, the climate model, okay, the exchange climate model. Okay, so in such a way, this drainage could cope. Okay, the extreme changes. Okay, extreme changes due to this weather difference. I hope that will answer my questions. I will pass it back to Dr. Siti Asma. And before that, I wish everybody a fruitful day and have a nice conference discussion on for today's conference. Okay, thank you very much.
Thank you, Dr. Haryati. Due to time constraint, for further questions, you may scan the QR code and the question will be directed to Dr. Haryati Yaakob. Thank you all for attending. We hope you enjoyed the session. I will pass the session to the MC, Dr. Dayan Zulaika.
Thank you, Engineer Dr. Siti Asma Hassan and Dr. Haryati Yaakob. Ladies and gentlemen, we are excited to inform you that we will announce the Best Paper Award and the Best Presenter Award in the closing ceremony for today. You may join the closing ceremony right after the parallel session 7. But for the time being, all presenters are welcome to join your respective parallel session now. Thank you and see you later.
Ini Pak Adamnya belum masuk nih. Ini udah masuk gitu. Udah, masuk aja. Boleh?
By Infinid 2021 under the theme of water management. Now, the presenter for today are Adam Safitri is joined in this room. Okay, and the second is Mr. Ari Sentani. Okay, in this room, and the third is Dudu Mulyadi is the joined in this room.
Yes. Yes.
Not yet, yeah. And the fourth is Mrs. Mila Carmila. Yes. The fourth is Chutsucia Sylvia, and the last Mrs. Nor Najwa Irina Muh Azlan. We remind all presenters and participants to fill out the attendance form given at the chat box. Here are the rules. We can read the rules on regulation for the presentation. The first, presenter will be given 10 minutes for the presentation. The second, the timekeeper will announce twice. One is the 3 minutes left, and the second is your time is up. The chairperson will stop the presentation on time or turn on your microphone when the timekeeper writes time is up. Question and answer are only allowed after all presentation in this session has completely presented. Okay, our first speaker today is Mr. Adam Safitri. Mr. Adam Safitri is joined in this room.
Cek. Udah keluar? Udah. Yes. Bukan ini. Oh. Link ini bukan? Oh, bukan. Yes. Gimana?
Ini link apa? Iya, yang dikirim Pak Aktif tadi pagi kok.
Oh, beda. Berarti yang tadi ya?
Recording in progress.
Wherever you are, may be always health, and I am very happy to meet you. Introduce, my name is Adam Safitri. I'm a student at Unissula, at Fakultas Engineering Sultan Agung Islam Sultan Agung Islam University of Semarang, with the title of Analysis of Clean Water Service Capacity for Taman Tukmunal Indah Housing Cirebon Regas based on Geographic Information System (GIS). Plan of presentation: 1. Background on objective research, and 2. Description of location, and 3. Literature review. 4. Research method. 5. Results. 6. Conclusion, and 7. Closing. Background on objective research. Point 1. Population dynamic have very important effect on ecosystem, including those related to water availability. The availability of clean water is closely related to the condition of the population in area. The total population at the study site in the Sumber district in 2018 total 11,972 inhabit, and then water supply system from the Gusti Spring, which has a discharge capacity of 45 liters per second. Then central transmission pipe wide the diameter of 10 inch long 7,000 meters to the reservoirs with a gravity flow system. Geographical Information System or GIS provides significant improvement in the term of work quality and efficiency and optimization of resources, and also contribute to the management of water management database. Description of location in Indonesia, almost all regions have a drinking water supply system that is managed by a local company as the operator of regional drinking water service called the PDAM. PDAM Tirta Jati Cirebon has a drinking water supply system from Cigusti Spring, which has a discharge capacity of 45 liter per second through a transmission pipe with a diameter of 10 inch along 7,000 meters to the reservoirs with the gravity flow system. And figure 1 or PDAM office, figure middle, the layer of soil structure of the spring water, and the right figure hydraulic profile of transmission pipe. Some of the literature, this paper discussion the simulation of EPANET program and GIS program, and in general I take from previous research, and one analytic method of improve, and two EPANET is computer program that illustrates hydraulic simulation. Three new development are presented in this paper using QGIS 2.18 as a geographic information system. Then, then the following is the flowchart of the research method in this paper and some parameter data that must be entered to EPANET program. The data parameter, a pipeline network, number of customer, data logger, and more. And then from the simulation result of the EPANET program could include is velocity, pressure, head loss, flow, demand, and more. And then check EPANET result and check GIS result and quantity and quantity of the water simulation. This image of the location of the research in the paper. This is a location in the Taman Tukmudal Indah host complex with the population 36,000 people, located in Cirebon Regency and Sumber Subdistrict. In this housing also meeting in needs of clean water using PDAM water. Sampling observation were carried out. The specific house connection total 6 points carted around to the Taman Tukmudal Indah housing complex. As an example of this research, the test in this paper, there are 6 test moments selected randomly based on the classification of the number of families and the position of the location in the housing. In this figure, there is a table that explains the quantities associated with the times of using clean water simultaneously, as well as a graph that explains how peak hour of use
Recording
or in
stopped.
morning and evening. Clean water needs the needs For clean water, for house proportion is carried out through has connection. The category of Akman Kabudal in the housing is based on the monthly report of PDIM Tirtajati. The average usage is 119 liters per day per person. The graphics relationship above is a comparison between the unit of time and unit volume of usage for 1 week with the 24-hour service. The result above show the high water discharge and the pressure peaks of hours is 0.016 to 0.018 meter cube. The clean
Recording in
water
progress.
continuous analysis, the continuities of the Minister of Home Affairs number 47 of 1990, namely customer get distribution for 24 hours. Another service indicator is normal air pressure, 0.5 and 1 meter bar atmosphere can radiate 5 until 10 meters. The graphic relationship above is a comparison between the unit of time and the unit pressure for 1 week with the 24-hour service. The result above show the highest water pressure to node 50 occurs on the Thursday at a measurement at 0, while the lowest is the Sunday at measures 7 at 6. Result and discussion for table 3, average consumption meters or house connection for months and months January, February, March, April, May, June, July, and 20 and then years and 2017, 2018, 2019 with a total population subscriber in 28. Average consumption in the years of the 2070 and 2018 is different monthly, and what average consumption 27 color is black dot. Okay, thank you.
Now, please allow me to call upon the next speaker, Mr.
Oh, betul. Okay. Belum masuk, belum?
Belum ada. Mr. Dudung Mulyadi is not yet in this room.
Yes.
Oh, okay. Mr.
Yes,
Dudung
this is
Mulyadi.
Dudung Mulyadi.
Okay.
Yes.
Mr.
Yes.
Dudung Mulyadi that will present his paper entitled Analysis of the Availability of Water Resources Using the Thornwet Metal Water Balance Method with Dual Reservoir Development in Residential Location and Tangerang Regency. And now, Mr. Dudung Mulyadi, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. I am Dudung Mulyadi from Unissula, Semarang, Indonesia. In this opportunity, I want to present my research, the title Analysis of the Availability of Water Resources using the Thornwet Metal Water Balance Method. with dual reservoir development in residual location in Tangerang Regency. Introduction. Background. Water resources are very viable reserve and will need a greatly affect the water resource crisis. Water footprint in the indicator of the water use where water consumption and pollution and included, they can also be applied to expand the water resources evaluation system and provide water use information for decision making. Consumption pattern without paying attention to sustainability can lead to a water resource crisis. The problem is a crisis of water resources in caused by population growth and increasing population density in urban. If what we use rainwater can be done by calculating the water balance. Tiga Raksa district located in western far to Tangerang Regency, Indonesia, with an area 53,798 kilometers. Tiga Raksa Regency has 14 administrative council consisting of 12 villages and 2 sub-districts. Picture 1. This is Tiga Raksa District, Tangerang, Indonesia. This object research purpose to find out the amount of surplus or deficit of water in 1 year in Tiga Raksa District and knowing the volume that can be accommodated by the double reservoir. Method. Location. Location Tiga Raksa District, Tangerang, Banten, in Ciomas, Bogor, West Java, Indonesia. Method. Method use experimental research method in laboratory and this study use design method and data collection obtained from the analysis of the result provided by tool. The tool and software. The tool needed are ultrasonic sensor, reservoir 1, reservoir 2, alternator, torrent cable, controller, ESP8260 microchip, battery, scalar, pump, laptop, and Arduino program. These two work by using a power supply that come from an energy efficient solar cell. Sensor detect deep water level and rainfall, then send the information to the microcontroller. The system then send this information to the mobile phone using the Blink application. Previously, this application had to be downloaded in the file store and connected to the microcontroller using the Arduino program. This tool works by using a power supply that comes from energy efficient solar cell. Sensor detect water level in rainfall and send its information to the microcontroller. The system then sends this information to the mobile phone using the Blink application. Previously, this application had to be downloaded in the Play Store and connected to the microcontroller using the Arduino program. Data processing for water balance calculation using the convert matter method. Q equal to minus ITE more or less delta S, where Q is followed in millimeter, P is rain in millimeter, ETA is actual evaporation in millimeter, S is change in soil moisture resources in millimeter. Result and discussion. The following show the rainfall data for Tangerang Regency during the 2050 until 2018 period. This is tabel rainfall in Tangerang Regency, January until December. The next, Tangerang Regency month average temperature data during 2018 period can be seen in the graph below. Picture 2. This is about Tangerang Regency monthly available temperature. Water deficit condition occur in the dry season in less rain month to overcome them using the reservoir. To prepare a reservoir that set the need, it's necessary to know the consumption pattern of the population and the number of people living in area. Construction of several reservoirs can be carried out at the district level and at the sub-district level. The calculation of individual and household water need is based on the standard of the Ministry of Public Works. Individual need 1,020 liters per person per day. Minimum water requirement for one family consists of bathing, washing, and latrine activities. Next, estimated water demand for Tiga Raksa district. Total population is 161,163. Daily water need is 19,130,160. Assuming on family consists of 4 people, then the number of family is 40,283. Household standard need is 126.9. Total standard house need 5,111,930.7. Reservoir filling using groundwater and rainwater using a head sensor to monitor the level automatically. Based on the use of microcontroller to control the water level in reservoir has been widely carried out, one of which is by Mulyadi et al. 220 and research conducted by Yana et al. 2000. Calculation 4.1. Calculation of the water balance in an area can period provide information about the amount of surplus and deficit in groundwater so that it can provide an overview of the availability of water in this area. There is water surplus and the width month from January to April, with the amount of water between 25.07 millimeter and 186.09 millimeter. The water deficit occurred in the dry month from July, October with a magnitude between 100 to 27 millimeter and 219 millimeter. 4.2. Dua reservoir planning provides water availability for a residential area so that it can help overcome the problem of drought of water deficit in the event of dry season. Utilization of rainwater is an alternative source of clean water for in area. Thank you.
It's my turn, right, Miss Hermin? Because I didn't hear your voice.
Yeah. Okay, Mr. Arisantani, I'm sorry. It's Mr. Arisantani that will be present his paper entitled Fluid Behavior Analysis on Liquefaction using Corinofaction Device. Mr. Arisantani, time is yours.
Thank you, Miss Hermin Pujastuti. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Let me introduce my name. My name is Aris Nane. I come from Unissula. Right now, I will present about fluid behavior analysis on liquefaction using corinofaction device. This is my presentation. For the first is introduction, and then followed by literature review. And number 3 is research methodology. And then we got the results and the conclusion. Indonesia is the part of Ring of Fire, and that's how many earthquakes happen in Indonesia. And the one of the big earthquake is happened in Palu, and Sigi, Parigi Motong, and Donggala. This earthquake has a 7.4 Richter scale in the depth of 10 kilometers in Palu Koro Path. And beside the earthquake in Petobo, also in central Celebes or central Sulawesi, this earthquake followed by liquefaction. So liquefaction is closely related to water due to the amount and the movements of water. So the soil becomes so liquid, and then it moves all of things in the above in the earth. And liquefaction is a phenomenon in which water saturated sandy layers of earth act like liquids. So the soil, we can see this, it's separated by water. And then the lateral movement can create uneven ground damaging the structures. This is the normal pressure of the water. And then for the liquefaction, it becomes intense. Force from an earthquake causes the water to increase in pressure. This picture shows how liquefied soil become so dangerous. This is the stable soil. In the topsoil, this is the topsoil and sand, and then this is the water table. So the liquefaction it depends on the water table. We know it, and then when during the liquefaction, after of course after the earthquake, the land is become landslide, and then the water of from the below it becomes to above, and it affects the sand in above. And then this is the criteria for liquefied soil according to Young, Day, Perlea, et al., and Puri. The soil diameter is D50 between 0.02 until 1 millimeters. And then content of fines grain diameter is less than 0.05 millimeter or equal to 20%. The coefficient of uniformity is D60 divided by the 10 is less than 10, and the relative density of DR is less than 75%, and then plasticity index is less than 30%. And now I will introduce the liquefaction, corinofaction. Corinofaction device is a device that developed by Engineering Faculty of Unissula, initiated by Dr. Indah Karanasari and Dr. Sudarsono in 2009. And then my team developed the latest version of coronification. Actually, it's related to shaking table. It's like how we can simulate the earthquake and then the liquefaction. We can see this is liquefaction how become dangerous and they go through the soil and make the soil unstable. This is my research methodology. I used to kind of soil, silty sand and silt soil I got from Kali Opak and in Yogyakarta and Kendal. I choose the two kind of soil because in these two area I choose in South Java and the North Java because these two places has a potential liquefaction. So I compare it, try to compare it, and then use it in the coronification. This is the device. So we have some glass box here. And then we have the motor servo in here to make the device move like a shaking table. And then we have the wood pulley in here and fan belt. We have also bucket in here. The function of this bucket is how we can move the water into the glass box. And then this is glass box we will fulfill by the soil. Okay, this is the result of my research. From the two soil types, we find for the Q, for the silty sand, it's about 0.0006769 meter cubic per second. And then for the gradient hydraulic is 4.76. And then for delta H is 0.03.
3 minutes left.
Okay. And then for Darcy is 4.67. And for the silt, we've got bigger for the gradient hydraulic, we can show. And then for the Reynolds and fruit, we've got silt descent is bigger than the silt. It's also happened in fruit. This is the liquefied area. We can see for the silt is more white than the silt sand in the liquefied area. And then the depth, we have several depth here, but in overall, the silt is more, they can defend from the liquefaction. For silty sand is more self-settlement. This is my conclusion. The result of my research showed that silty sand and silt was liquefied in 8 modified Mercalli intensity earthquake and caused the occurrence of water flow on the surface due to increased soil pore stress. The flow rate is in the silty sand is 6.769 multiplied by 10 to the power 5 meter cubic per second, and silt is 5 multiplied by 10 to the power minus 5 meter cubic per second. And then the water flow that flows in the silty sand had a permeability of 4.76 multiplied by 10 to the power of 4 centimeter per second, while on the silt is 6.09 multiplied by 10 to the power 4 centimeter per second. After liquefaction, gradient hydraulic of silty sand is 4.76 millimeter and silt is 6.09 millimeter. Based on this research liquefaction, we can find the debris flow and multi-debris flow in the soil. Thank you. This is for my presentation. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you to Mr. Ari Sentani. Now, please allow me to call up the next presenter, Mrs. Mila Carmila, that will be present is her paper entitled Women's Right to Water, strategy for fulfilling water in Semarang coastal area. Mrs. Mila Carmila, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Everybody is already hear my sound, my voice. Okay, I will start to present our research. This is a little big, little part of the research is going in grown up. There's a NGO that's give water literacy. This is my, okay. I chose the title is Women's Right to Water because we know sometimes that women cannot have access to good water. So this is the location is in coastal Semarang area. You can see in this situation how suffer women to have good water, to good water, not only good water but to have a water. It's not easy to. So we know that Asia, including Indonesia, are the mostly challenged by both water abundance and scarcity. And now we know that Indonesia maybe is the one of the country that have scarcity because in the rainy season there's many much water, and in the dry season there's no water. Okay, this is my introduction, and this is my introduction too. We know that cultural and historic, women are often primary collectors, transporter, and user of water in developing countries. So women must obtain the water and make sure that in the family the water is already have. Earth, water, and natural resource embedded that are regulated by state and used for greatest prosperity of people. We know that this is the Undang-Undang Dasar 45, especially in Pasal 33, Pasal 33. We said that earth, water, and natural resource embedded that's regulated by states. So we must know that state must obtain the need of water for everybody, not only for men, but for women and vulnerable people. So, however, this not include women needs for access to clean water. And I use ecofeminism to see how suffer for women because of water. This is the method here. We use multi-stage stratified sampling. The location is North Semarang and Genuk, and the village is 5 village. In North Semarang is 3, and Genuk is 2. The Kuningan, Panggung Kidul, Panggung Lor, and Terboyo Wetan and Terboyo Kulon. We have 100 respondents, and we use subpopulation is the location is critical. Critical, it means the location is have many problems. Not only they don't have good water, but only they have a problem of tidal flood or inundation and flood and then land subsidence. So we use the location because they have many problems of water. Not only the good water for fresh water or drinking water. This is the variable of water. There's distance, cost, number, and time. And ecofeminism is about gender and water. This is the location. The location we saw that in Genuk Semarang, beside the settlement, beside the settlement, they have many kind of industrial. So in this location, not only settlement, but they have industrial too. In Genuk district, they have 22 industrial, and the employee is about 3,000 3,500 employee. So maybe everybody can imagine how very dense in the location. And the second location is North Semarang. The location of North Semarang is near from the port of Tanjung Mas port, near from the location. And then the people in the North Semarang is fishermen. So this is the difference between North Semarang and Genu. And this is the characteristic of the respondent due to the questionnaire. According to the data, the majority of the respondent in Genu is about 50 years old, and the duration of the stay in the location is more than 20 years. So I think this many information that we can have, because they already stay in this location 20 years. And the family members is about 3 until 4. In the north, the respondent is about 41 until 70 years. And it's the same with the Genu district. They stay in the location is more than 20 years too. And the family member is about 3 until 5 people in this house. And this is the result of the study that I will show everybody here. This I use 8
3 minutes left.
8 variable, and the type of water use, expense for non-drinking water, kind of purified water, water quality and water access issue, reason to use artesian well, and losses suffer. Maybe if anyone have a question after this presentation, I will ask, because the time is only 2 minutes. I will show the result too. Based on the result, it can be seen that according to the theory, access to water supply, which consists of cost and amount, the water usage, there is different type water use in North Semarang and Genu. Genu only boiled the water, but we know that in Genu, they have many kind of industrial. And from other research, we know that in Genu, they have a potential of water pollution is very high. So everybody can imagine how bad the situation of water in Genu district. And so already maybe it's polluted and contaminated, but I don't have other research to show about the contaminated water in the Genu. And another result that some women pay more than men in the term of water fulfillment in location is about 100 rupiahs until 300 rupiahs for half water. So this is the situation of 2 locations in Genu and North Semarang. And then water and women are one of issue concerning the right of to water for women and other vulnerable people, even though environmental and gender issue have widely been discussed. Women continue to face significant challenge in the implementation, both in terms of quality and quantity. This is the conclusion. According to the study, women are the ones most affected by existing condition into district, both term of access and impact of unfriendly development of women, because we know that in the location they have many kind of building. There is industrial and there is a port, so we know that this location is already very polluted. So how we can ensure that women have a fresh water or a quality, good quality for their life. So the suggestion is support activity that train and empower women, ensure that women and men are given equal attention in promotion, water, sanitation, and hygiene and training activity.
I'm sorry, Miss Mila's time is up. Okay. Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mrs. Mila Carmila, for delivering such interesting presentation. Now, please allow me to call upon the next speaker, Mrs. Jutsutiatina Sylvia. Have you joined in this room? Okay. Miss Sutiatina. Tadi kayaknya sudah masuk, saya admit. Okay. Okay, Mrs. Sutiatina Sylvia, have you joined in this room? Okay. Okay. Okay, now the Mr. Jutsutiatina Sylvia, they can the video presentation will be present this her paper entitled Analysis of Water Distribution Systems and Head Losses Using the Hardy-Cross Method. Yes. Okay. Yes. This is the sound is ada suaranya. The sound is not clear. Pakai mic.
Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to introduce myself. My name is Jud Suchatina Sofia. I came from University of Teguh Umar, Aceh. I want to present about analysis of water distribution system and head losses using the Hardy-Cross method at International Forum on Integrated Infrastructure Development, September 2021. Pipe network problems almost entirely occur in clean water pipelines, so that water needs that reach customers are not optimal, as happened to PDAM Tirta Melaboh. Sylvia has conducted a study performance analysis of the clean water network distribution system at PDAM Tirta Melaboh to see a condition of the performance of the clean water distribution networks and the problems of water losses that occur in PDAM Tirta Melaboh. And the result of the analysis obtained, the network performance system is not satisfactory. Condition of the existing problems water distribution system in the area sub-district John Palawan, such as water loss and leakage from a water network. This research was conducted to analyze head losses using the Hardy-Cross method on the PDAM Tirta Melaboh pipeline network. The benefits of research can also be input to PDAM Tirta Melabu to improve the water distribution network system to improve clean water service, especially at John Palawan district. The Hardy-Cross method is a very simple method for hydraulic analysis of water supply networks. In analysis, the entire loop network, the Reynolds number, friction factor, flow resistance, head loss, change in pipe flow rate, and corrected flow rate for each pipe in all specified loops will be obtained. Based on the Hardy-Cross procedure, pipe also runs a series of iterations until the network is completely complete. The method. This research was quantitative and survey method. The implementation of the research check the discharge data, water pressure data, and water usage characteristic, and then calculate population projection and analyzing analysis using Hardy-Cross method. The steps for completing the analysis using the Hardy-Cross method are as follows at the slide. The first, the distribution of the bit, and then calculate losses for each pipe. To calculate the power loss in pipe from the pipeline data and pipe diameter obtained from the PDAM, and then calculate the friction factor, and then calculate the error correction. Measurement is made only once delta L, so that the power loss in the network is balanced. And then this is a figure research flow chart. For results and discussion, from the graph can be seen of average water discharge. It can be concluded that the highest water usage time is the peak water usage time. This shows that the community carried its activities at this time. And then for the results of the water research can be seen at the graph of the maximum and minimum water pressure analysis. The analysis of the water pressure results that have not reached the minimum water pressure to the customer of 1 ATM. And for the production capacity is 80 liters per second. So that the pump PDAM must replan the planning to increase the clean water production capacity of WTP at Lapang to 1 unit, which will be able to serve the needs clean water in the Johan Pahlawan district. And for analysis using the Hardy-Cross considers the characteristics of pipes and flows that enter and leave the pipeline network to be known, and the discharge will be calculated for each element of each network. The figure is the assumption of direction and flow rate discharge in pipeline. A loop pipe network at the study site where there is a network of loops, node pipes, and the direction of water flow in the pipes. After the loop network is created, then the next step is to analyze the data using the Hardy-Cross method as described through the previous stage or steps of completion. This analysis is carried out repeatedly with iteration until the delta L reach 0. Then correct the direction of the flow from the initial flow to the new flow. From the figure, The assumption the pipe flow at 29 in loop 10 is the opposite direction as in figure, but there's a change in the flow direction in the fifth iteration process with a positive flow direction. And then no more change in the flow direction. Meanwhile, the final result of the iteration calculation process carried until the seventh iteration. Until the seventh iteration, the flow direction does not change again. This is figure change in the direction of pipe flow 29 in loop 10 after the fourth iteration process. So the iteration process is carried up to 7 times the iteration process because from the analysis until 7 iteration, the analysis data doesn't change. This is table for results of iteration, first iteration and 5 iteration for samples analysis. The conclusion, pipeline analysis using the Hardy-Cross method is easy at the level of the calculation process because large pipe networks can be divided into several small loops. And then from the calculation results, it can be concluded that the result of the Hardy-Cross method. From the analysis, maximum pressure is found in loop 7, and then the minimum pressure is in loop 6. However, to check the level of accuracy of the Hardy-Cross method calculation, it's better if the calculation result can be compared directly using computer simulation software with EPANET or etc. That's enough. Please input and advice from all. Thank you.
Okay, thank you to Mrs. Tutsutia Sylvia for delivering such interesting presenter. Now, please allow me to call upon the next speaker and the last speaker in this session. Now, the speaker is Mrs. Nur Najwa Irina Muazlan that will be present her paper entitled Water Demand Management at Rural Area Using Micro Component Analysis, a case study at Kenyir Lake, Malaysia. Mrs. Nur Najwa Irina Muazlan, the time is yours.
Thank you to the chairman. I am Nur Najwa Irina binti Muhammad Azlan. Today I'm going to present to you my paper on water demand management at rural area using micro component analysis, a case study at Kenyir Lake, Malaysia. So the content of my paper include introduction, data description, model description, result and discussion, conclusion, and also references. Okay, for introduction, to build a stable rural communities, we need an evolution of agriculture, water resources, service of public health, infrastructure, and tourism of rural areas. It can be promoted through campaigns and programs. Okay, so I want to highlight here. I highlight the water resources. So what I did was predicting a water demand, which is significant for design and operational demand. Also, the estimated water demand will provide a data of present and future water consumption of a fixed period. Okay, by choosing a reliable water estimation model with a good set of available data increases the accuracy of the result. So the objective of my study is to conduct water demand study at Kenyir Lake using micro component analysis, MCA, and also National Water Service Commission's SPAN guidelines. This is the Malaysian's water requisite. And the second objective is to compare the results of estimated water demand using MCA and SPAN guidelines. Okay, next is scope of work. Okay, I divide it into two, which is study area and data collection. So my study area is at Kenyir Lake, Terengganu, Malaysia, and the lake area covers 260,000 hectares. And it is developed to generate hydroelectric power to provide electricity all over Peninsula Malaysia. And the data collection will divide by two, which is two methods I use. MCA. MCA will need proportion of each appliance's use, frequency of water use, and volume of water use. And also the SPAN guidelines will need data on average daily water demand from the guideline and also multiplying factor. Okay, the data description. So this is data that I collected to calculate water demand using method MCA or micro component analysis. So this is the ownership level. We divide the proportion level according to the appliances use. So the proportion is set based on the highest and lowest water usage at end use activities at Kenyir Lake. Okay, and then this is also the data of frequency and volume of water use and also multiplying factors at Pekalang Gawi Kenyir Lake only, a part of Kenyir Lake only, because if I want to include all the data at Kenyir Lake, you will get a lot. It takes a lot of space here. So at least you can see an overview of how the data is. So I will collect the data on frequency according to the appliance use also, and also the multiplying factors. The multiplying factors is based on how many people can fit in a premises. So these are some of the premises: Lawit Lodge, Ketengah, and food stalls and more. Okay, for the data on SPAN guidelines is actually the average daily water demand from the guideline itself. So this is the selected average daily water demand according to type of premises that is at Kenyir Lake. Okay, you can see in the table 4, and the ranges are from 50 to 1,500 liters per unit. Okay, and for the model description, so this is how the method goes. So MCA model focuses on water flow at micro output such as toilet, kitchen, and sinks. So that's why we take the data from each of the appliances. Okay, so the water demand is calculated by the per capita consumption, PCC, as you can see the formula in the screen. So PCC is per capita consumption, O is proportion of appliances used, and F is the frequency, V is the volume. PCR is per capita residual demand. So PCR is actually a fraction of per capita consumption. It acts as emergency for the premises. So it's taken a half from the total per capita consumption calculated. And for SPAN guidelines, the calculation we use is water demand equals to average daily water demand from SPAN guidelines times the multiplying factors. Okay, so the result and discussion. So this is the result, one of the calculation from a premise at Kenyir Lake, which is premise of offices of Ketengah and Tourist Information Center. As you can see, we calculated per capita consumption, per capita residual, and we'll go and get final per capita consumption. And it is recorded at 5.4 meter cube. Okay, so these are all the water demand at each premises are required. Okay, as you can see, the total daily water demand at Kenyir Lake estimated using MCA is 1,249.8 meter cube. And the highest daily water demand is for houseboat, which is 662 meter cube. This is because houseboat is a famous mode of water transportation among tourists that go to Kenyir Lake. And also, houseboat is a major ecotourism business at Kenyir Lake. It recorded at a percentage of 74% compared to speedboat operators and other ecotourism business. And for the lowest recorded at camping site, this is because camping sites have no appropriate facilities or toilet or for water required. So the campers also prefer to use a lake and stream water or water from public toilets provided from the camping activity. Okay, for SPAN guidelines, the water demand value using SPAN guidelines at Lawe Lodge is calculated as shown in the screen, which is it gets 15 meter cube per day. And these are the results of daily water demand calculated using SPAN guidelines. Okay, so the total daily water demand at Kenyir Lake is estimated at 1,254.1 meter cube, and also the highest daily is also recorded at Houseboat. Same reason as MCA just now, and the lowest water demand is Tropical Park, 0.8 meter cube. Okay, the Tropical Park may caused by its short service of operation, which is from the year 2015 to 2017 only. Only few tourists have chance to explore the park since it has short service of operations. Okay, this is a comparison. It shows a small difference between both of the method. MCA is more accurate because it's considered all water appliance used as well as the water activity and number of tourists. And also micro component data let data to be accessed at its micro scale. Okay, implementation of water and use data has become a basis for water demand evaluation across the world. Okay, in conclusion, water demand estimation has a slight disparity between both of the method. Low and high water demand at each premises should get an attention from the authorities, and the implementation of MCA, micro component analysis method, applicable for other lakes too with limited data of water supply. And what I can recommend here is that further exploration is required using other method of analysis such as fuzzy logic and statistical analysis. And okay, lastly, the references. So these are the references that I use in this paper. Okay, thank you.
Okay, thank you, Mrs. Nur Najwa Iriana Aslan, for delivering such interesting presenter. Thank you for everyone. We are done with all the presentation for parallel session 5. It's time for question and answer session. In the chat box, there's several questions to presenter that will be answered as for the presenter. Mr. Ari and Mrs. Mila, have you the additional answer to completing their answer in the chat box? Maybe.
Yeah, I think I tried to answer it for Prof. Thank you very much for the question. The main case of liquefaction is, of course, the earthquake, because the soil must be shaking to become more loose and uncompacted. So in some research, there's no more big case instead of the earthquake, but we also know in the soil has a special phenomenon. It's called internal erosion. I think in maybe in the next year or then a few years, we have to research about internal erosion because it can be more potential to get liquefaction. Maybe that's my answer.
Okay, thank you. Mrs. Mila Carmila, if you have additional answer for questions from Mr. Sahri and Mr. Imam.
Okay, I will try to answer. For the woman fulfilling the water in the coastal area, in the they use artesian well. They use artesian well to fulfilling the fresh water. But we know in the location is already polluted. So I think even they know that polluted, they don't have a choice to have other choice to have fulfilling the water. And then how to have fresh water? They boil the artesian well to have a good water to drinking. This is in the Genu, but in North Semarang because they have a PDAM, so they use PDAM to fulfill the water. Even they use a gallon water or refill water to fulfill the water. This is my answer to Mr. Iman, and then Mr. Sahri. Okay, about what the solution? I think the solution must point to the government, not point to the woman in this location, because the woman is I think there is a what is it, a victim or something like that, because they don't have choice to choose the location, and then the industrial in this location have already make the water in this location is very polluted. We know, you know, that in the location they have 22 industrial. We know that many of the women in this location become, I think, become the victim of the situation. So maybe the government must have a solution for the people who are affected. Thank you.
Okay, thank you, Mrs. Mila. And now we move the next question from Mr. Sahri and Mr. Imam. To question is to deliver to Najwa Azlan. Maybe you can explain the.
Okay, yes, sure. Okay.
Yeah.
So for a question from Dr. Ahmad Shahri, on houseboat, yeah, houseboat is, I need to take as one component of one premise at Kenyan Lake, because houseboat is actually tourists use houseboat to have their accommodation when they go there. So actually the demand is really high when there's tourists use the houseboat. That's why I calculate houseboat as a premise that need to find the demand lah, the water demand. Okay, the breakdown on what the water used inside the houseboat, is it? The normal breakdown of water that we use in the houseboats, like toilet, for kitchen, and also for cleaning. All the water end use that I mentioned in the slide, there are all the components that I consider in houseboat. Okay, and for question from Prof. Imam, okay, how many? Okay, correct. So the parameter that I use is the water end use data, which is on each of the appliances I use to calculate the water demand. This is because there's more parameter that I can use. But for Kenyan Lake, due to limited data that they have, just like for like water, they don't have specific water data from water companies. So I need to go through other type of data, which is I choose water and use appliances data to calculate water demand per day. Yeah, it is water demand per day that I calculate water demand just now. Okay, that's all.
Okay, thank you to Mr. Nur Najwa Irianamu Azlan for your answer. Ladies and gentlemen, I'm sorry if the time is up for the session. Before end, I would like to invite all of you to take a group picture. Please turn on your camera. Mrs. Mimi, please. The first slide. Next. Okay. Okay. Okay, thank you. Finally, applause for our speaker and participant. Okay, kind reminder, don't forget to attend the closing ceremony and at the 14 till 5 p.m. in West Indonesian time, or in 15 and 4 p.m. Malaysia. Thank you for everyone. Have a good day and Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Bu Hermin.
Thank you.
Assalamualaikum warahmatullahi wabarakatuh, ladies and gentlemen. Welcome to parallel session 6, ICCDA, and Infinid 2021 in theme construction and material and technology. My name is Abdul Rahim. It's a great pleasure and honor to be the chairperson for this session. For the rule, let me explain the guideline for all the presenters here. You have only 10 minutes to present your paper, and our timekeeper will remind you on 3 minutes left. For the question, for all the participants and presenters in this room, you can write down your question in the chat box or just raise hand. We have four or five. One. Yes, we have 4 presenters in this session. So I give the time for the first presenter, Mr. Damang Budi Cahyono. He will present their study entitled Lightweight Concrete as Cover on Floating House Platform made from Expanded Polystyrene System or EPS material. Damang, time is yours. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I would like to say thank you for coming to my presentation. I am glad to see you all, ladies and gentlemen. Let me introduce myself. My name is Damang Budi Cahyono, and I am from Sultan Agung Islamic University, Unissula. In this presentation, we will discuss about liquid concrete as cover on floating house platform made from expanded polystyrene system material. Introduction. Coastal areas often get flooded due to high tides and rising sea level. In turn, will have negative impact on the socio-economic life of residents in coastal areas. In order to minimize such impact, innovation for a more environment. The advancement in the construction what has introduced floating house may become a solution for that. Floating house equipment with platform in liquid concrete cover made from expanded polystyrene system may fulfill such need. A liquid concrete cover on floating house platform made from styrofoam will improve the aesthetic of residential visibility, especially in terms of strength from comfort on cleanliness. This is a liquid concrete cover. This result I am to determine the characteristic of styrofoam and to determine the volume, weight, and the compressive strength of concrete by using styrofoam as a substitute for the coarse aggregate. Literature review. Floating house is a building construction that is built above or float of water surface in uses of foundation system that has a high clearance force. The foundation platform is structural that hold entry back of the building above it. Styrofoam platform is for effective and efficient compared to PVC platform. Andayani state that styrofoam is one of the material that has low density. Liquid concrete, according to the Indonesian National Standard 03847/2002, any concrete can be classified as liquid concrete is weight less than 1900 kg per meter cubic. While normal concrete is a fairly heavy material with its own weight, is to up to 2400 kg per meter cubic. Is this research, the composition of liquid concrete material were determined based on the volume comparison and carried out the interface general with variation in ratio between cement and sand and styrofoam, and with the value of the thickness of the mixture using a 60 to 100 millimeter slam. The compressed strength of liquid concrete based on the Indonesian National Standard 03174/1993, the compressive strength of concrete in the amount of load per unit area which may cause the deduction of the concrete specimen when loaded with certain compressive form generated by the compression machine. The compressive strength of concrete is represented by the maximum tension FC in kilogram per centimeter cubic or MPI unit. Based on the compressive strength, concrete can be divided into several types as shown in table 1. The type of liquid concrete vary based of weight, compressive strength, and control constituent aggregate, but these factors are refined in the Indonesian National Standard as shown in table 2. Reset method. This reset consists to 3 steps. 1, testing the aggregate characteristic. 2, making a mixture design plan. And 3, testing the weight and compressive strength of liquid concrete. The material which we use cement from PT Cement Gresik, fine aggregate, sand from Muntilan District, Central Java, and styrofoam. Result and discussion. The result of testing the characteristic of fine aggregate and styrofoam as weight concrete forming material obtained as shown in table 3 and 4. Composition of liquid concrete mixture. The concrete mixture plan consisted of using volume ratio mixing method, determining a cement water ratio of 0.38 and using a 50 to 60 millimeter concrete sum. 1, a composition of mixture. 1 BC, 2 sand, and 3 styrofoam. 2, a composition of mixture. 1 BC, 1.5 sand, and 2.5 styrofoam. And 3, a composition of mixture of 1 BC, 1.25 sand, and 2.75 styrofoam. For making 15 cylinder sample for X testing 7, 14, and 28 days. The following the mixture of calculating the job mix design of each mixture. Table 5. The volume weight of fresh concrete according to the result of this reset. The weight of concrete are belong 1900 kg per meter cubic. Therefore, the concrete belong to the light weight concrete with the average weight of concrete 1000 to 2000 kg per meter cubic, as on being the result. The liquid from concrete weight 1097.88 kg per meter cubic was obtained from the mixture of 1 BC, 1.25 sand, and 2.75 styrofoam. The result of making cylinder specimen 15 to 30 centimeter after a compressive test on the characteristic of the compressive strength of concrete with a composition 1 BC, 2 sand, and 3 styrofoam. Is shown in table 6, table 7, and table 8. Table 6, table 7, and table 8. Given on table 6, the compressive strength characteristic of 107.13 kg per centimeter square was obtained. Table 7, 84.73 kg per centimeter square, and table 8, 71.93 kg per centimeter square. Based on the classification of concrete quality, the result above are included in the category of concrete quality B0. Where the compressive strength characteristic of the concrete characteristic less than or equal 100 kg per centimeter square, these concrete are non-structural. Well, in table 6, the compressive strength characteristic of concrete is a greater than or equal 100 kg per centimeter square. Conclusion: from the result of the data analysis, it can be concluded that the lifting weight of concrete 1097.88 kg per centimeter cubic can be obtained from the mixture 1 BC, 0.7, and 2.5 styrofoam. Thus, the mixture variation of 1 BC, 2 sand, and 3 styrofoam with the compressive strength value 119.26 kg per centimeter square and the weight of fresh concrete 1279.89. And based on the classification of the quality of concrete is also included in the category of quality concrete above B0. Concrete where is greater than 100 kg per centimeter square. This mixture variation can be used like weight concrete cover on floating house platform made from styrofoam. Question: while making the test object, make sure there is no separation among styrofoam, sand, and cement. The material must be put in a mixture according to the following order: water, styrofoam, and sand. A slump that is too high may cause styrofoam granular to float in the mix. The compressive strength characteristic created in this sheet is not recommendation for structural concrete, but only to be used as a leak-back concrete cover on platform for floating house. It will further be developed in the future research. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Pak Damang, for your presentation. The next presenters will be Mr. Ignatius Sudarsono.
Yes, I'm here.
Okay. Okay, time is yours, Pak.
Thank you, Bapak Moderator. Okay, I will start the presentation. Assalamualaikum warahmatullahi wabarakatuh. In this occasion, I will present the paper by title Effect of Zeolite on the Comprehensive Strength of Concrete with Different Type of Cement in Coastal Area. For research background, we know concrete is one of the main. Okay, sorry.
We can't hear your voice.
Okay, I'm continue my presentation.
Okay.
The research background, you know, concrete is one of the main materials in coastal area construction. Currently, a lot of construction is being done, so demand for concrete is increasing. The various innovation in concrete mix have emerged intending to improve the quality of the concrete, including the value of the compressive strength of concrete. One of the innovation is to add zeolite in the concrete. Mineral zeolite can be classified as a pozzolanic material because zeolite contains silica up to 62.75%. The zeolite used in the study came from Tasikmalaya, West Java, Indonesia, and the result on the zeolite mineral composition carried out at the Laboratory of Coal and Mineral Technology or Tekmira, Bandung. In the table 1, we can see the mineral composition. For aggregate, test of concrete materials carried out on fine aggregate and coarse aggregate in this study included testing of specific gravity, water absorption, silt content, shift analysis, and cavity density. In table 2, we can see fine aggregate test result. The result test is mass content, box specific gravity, and grain modulus. The description of result test is qualified. For table 3 show coarse aggregate test result. And table 4 below, we can see the specific gravity of material test result. For slump test value, from the result of concrete mixing, is variation of the mixture has a different slump value. In table below, we can see for ordinary concrete, the slump value is 10 centimeter for BZ 15%, The slump value is 8.5%, and BZ 25%, the slump value is 10 centimeter, sorry. The slump value of the concrete is still in ideal range of 8 to 12 centimeter. The material used in this research are coarse aggregate and the fine aggregate. Water, cement used is type 5, which this for sulfate resistant concrete, and mineral zeolite type clipnotillolite. 3 variations of zeolite are used, namely concrete with zeolite content of 0%, 15%, and 25% of the cement weight. The compressive strength test was carried out when the specimen were 15, 28, and 36 days old by using a compression testing machine with the quality of the concrete design mix is FC prime 35 megapascal. The permeability test of the concrete was carried out at the edge of 28 days using the parallel permeability test tool. However, this research is intended for concrete in coastal area. So in the permeability test, users see water. The standard for applying pressure is 5 kilogram per centimeter square for 3 days. This is this figure show the permeability average from the test result. We get for VN or ordinary concrete, the permeability average is 1.7 centimeter, and BZ 15%, we get 2.17 centimeter, and for BZ 25%, we get 2.7 centimeter. At the end of 36 days of concrete, the value of concrete BZ 15% is close to the value of concrete without zeolite or ordinary concrete. While for BZ 25% from the beginning of the formation of concrete until the age of 36 days, the value of compressive strength remains below the concrete without zeolite. The value of ordinary concrete and BZ 15% has exceeded the compressive strength of the design concrete, which is 35 megapascal. But for BZ 25% has not reached the expected value. Table 6, Table 7, and Table 8 show the compressive strength at 15 days, 28 days, and 36 days. We can see the value from each table. The compressive strength of concrete BZ 15% is getting closer to the value of ordinary concrete. On the edge of 15 days, it will exceed the compressive strength of BN, which will 47.8 megapascal. The result of other research, namely Ahmadi and Serkachi, who use cement type 2, showed the concrete with zeolite at the age of 28 days reached 42.2 megapascal. And the result of Imam Esra's research, which used cement type 1, obtained the value of compressive strength of concrete with 15% zeolite at age 28 of 35.6 megapascal. Although the result cannot be directly compared to the study that have been carried out because there are differences in the origin of the material and other added materials such as superplasticity in the two studies. We can see that the compressive strength value of the mixed design can be achieved with the addition of zeolite 15% to 20%, exceeding the additional percentage of zeolite, the compressive strength does not reach the design value. For conclusion, the result of the compressive strength test on ordinary concrete have the compressive strength of normal concrete at 36 days of concrete age of 39.3 megapascal, and the compressive strength of 15% zeolite concrete of 38.65 megapascal. For the concrete with 25%, the compressive strength is 28.23 megapascal. Based on comparison with the result of other study with variation in different type of cement, it can be concluded the optimal value of the addition of zeolite to concrete in the range of 10% to 20%. For testing the permeability of concrete, from the test result, obtained ordinary concrete has the lowest water absorption value of 1.73 centimeter, then 15% zeolite concrete has 2.17 centimeter water absorption value. And the 20% zeolite concrete has an infiltration value of 2.7 centimeter. This value still meets the requirement for the absorption limit, which is less than 5 centimeters. So that the use of zeolite percentage into concrete
Thank you, Mr. Ignatius. The next presenter will be Mrs. Ani Ustirini. She will present effect of sodium hydroxide concentration on the compressive strength of the mortar biopolymer concrete used fly ash Tanjung Jati, Jakarta. Mrs. Ani, the time is yours.
Thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh. Peace be with all of us. Good afternoon, ladies and gentlemen. I will present the results of my research. Permission to share screen. Sorry. This. Belum. Sudah apa belum? Ini sudah. Hah? Sudah. Sudah kan? Belum. Sudah. Ini. I'm sorry. Sampul. So, okay, background. Cement production contributes 7 until 8% of total CO2 at Malhotra. 2010, production of 1 ton cement equivalent production of 1 ton CO2. Impact, greenhouse effect, Richard David Defoe's 1994 and code 23. Let's reduce cement. Solution, use environmentally friendly concrete, low cement or no cement. Geopolymer concrete reduce CO3 emission by up to 80%, Research Chito et al. And Sumajo et al. Gak bisa nih. Bisa. Nggak mau. Ini aja. Ini aja kan? Research purpose, investigate the effect of in our concentration. Biarin kita aja. Please. Research purpose, investigate the effect of an our concentration of on performance of geopolymer mortar covering different concentration of molarity, 8 mol, 10 mol, 12 mol, and 14 mol. Research methods. Start literature study, preparation of tool and materials, mixed sand mortar geopolymer, FICA test, product geopolymer mortar, curing, compressive strength concrete test, analysis, conclusions, and segregation, finish. Procedure of making geopolymer mortar with all materials to form a geopolymer mortar according to the composition. Make a solution 8, 10, 12, 14 mole in hour the day before the casting. Make alkaline activator by mixing in our solution with H2SeO3 on the day casting. Prepare a container, a bucket, and mixer. Then put fly ash, fine aggregate, alkali activator into the container and mix well using a mixer. The process of making alkaline activator liquid from in our crystal to in our solution. Mixer binder and activator until evenly disturbed. After stirring until smooth, then pour into the mold and smooth the top surface. While flattening the mold, knock with rubber mill and knead with an iron to reduce air flow in the mold. Curing of geopolymer concrete must be carried out with special care, different from the treatment of concrete in general. The concrete is wrapped in plastic boards, then wrapped in wet socks on all sides. See, that's mortar 8, 10, 12, and 14 more. Before and after concrete compressive test, this picture. Result and discussion. We have 2 color blocks, green block 2 days, 8, and blue blocks 28 days. So 8 more for 24.18 to 32.38. 10 more 27.32 and to 21.96. 12 more 40.97 to 38.54. The last 14 more, the 34.85 to 24.76. Conclusion, the maximum compressive strength of geopolymer concrete mortar is reached at 12 mole in our molarity. At 7 days, it reached 40.97 megapascal, and at 28 days, it reached 38.54 megapascal. From 2 days to 28 days, there is a decrease in compressive strength of 5.9%. And our molarity that exceeds 12 mole affects the decrease in compressive strength of geopolymer. Geopolymer concrete mortar with 8 mole and our molarity experience an increase in compressive strength of 33.9% from 2 days to 28 days. From 24.18 megapascal to 32.38 megapascal. This is an input for my future research. Thank you.
Thank you, Tuane, for your presentation. The last presenters in this room will be Mr. Muhammad Husni Afiar. He will present
Ini laptopku gimana sih? Kok kayak
the study entitled Lectural Behavior of Full Height Rectangular Opening Castellated Steel Beam Using Different Size of Diagonal Stephanum. Pak Rusli, time is yours.
Thank you, Dr. Abdul Rahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Today I would like to present my paper research entitled Flexural Behavior of Full Height Rectangular Opening Castellated Steel Beam Using a Different Size of Diagonal Stiffener. The author is me, myself, Muhammad Rusli Ahyar, Prabowo Setiawan, Cahyotri Adinata, and Enggal Sukadana. Oh, I'm sorry. Okay, before I start my presentation, I would like to tell you about the presentation outline. Comes with introduction, research method, result and discussion, and finally conclusion. First, as we know, in the basic principle of beam theory, it states that the higher the steel section, it is better to withstand the moment force. So if we want to achieve a greater moment force, we also need to make a higher steel section. One method to make a higher steel section is a castellated process. So what is a castellated process? Castellated process consists into 3 or 4 steps. The first step is cutting the web of original section, original steel section, following the cutting pattern like in this picture on screen. The second step is splitting into 2 parts and also shifting and rotating one part into another in the second picture. The last step is to rejoining the 2 parts by welding connection, so we get the higher steel section compared to the original wide flank section. Okay, a different cutting pattern on the web section will make a different hole opening. Some non-opening hole in castellated steel beams are a hexagonal opening, like this picture, and any other is circular opening, and also rectangular opening. And now I would like to introduce you to the full height, another opening type. It is full height rectangular opening. The full height rectangular opening offer a higher section and project of castellated steel beam compared with a normal rectangular opening. Last, I state that the higher steel section, it is a higher also on flexural or moment capacity. However, this type of opening, a full height rectangular opening, comes with a weakness. It has a weakness that it is vulnerable into a Firendl failure mechanism. For plastic hinges take place simultaneously in a low. For plastic hinges take place simultaneously for 1, 2, 3, 4 in a low load pressure. As a result, the moment capacity drops into about 30% compared to the original wide flange section. The full height rectangular opening then to be strengthened with steel bar as a diagonal stiffener. Now the mechanism of variable is can be avoided, and the failure mode is now a normal buckling compression element, and then the moment capacity can be increased up to about 150% compared to the original wide flange section. Okay, now from that research, now come one big question: does the diameter size of steel bar as a diagonal stiffener has an effect on the moment capacity? To answer this question, we make a research method. We make a wide flange section of 200 millimeters. We made it into a castellated section, a height of 362 millimeters. The yield stress, we use the material steel stress 240 megapascal, and ultimate stress 370 megapascal. We make a 4 model of castellated steel beam: CB1, CB2, CB3, and CB4. Each has a different steel bar diameter as a diagonal stiffener. CB1 has a 10 millimeter steel bar diameter, CB2 12 millimeter, CB3 is 16 millimeters, and CB4 19 millimeters. We also set the beam span as long as 3 meters to avoid the lateral torsional buckling failure condition. For the method of analysis, we use two methods. First is stress system analysis, and two is pushover analysis. First, we calculate the moment capacity of wide flange, original wide flange of 200. We use the equation from Indonesian code SNE 2015 to calculate the moment capacity of a wide flange section. We get the moment capacity of a wide flange 200 about 48 kilonewton meter. Intra-system analysis, we evaluate castellated steel beam as a separate compression and tension element. So we just choose which one element is compression and which one is tension element. Upper flange section receive a compression force, while the bottom flange section receive a tension force. On the diagonal section, alternate between the compression and tension force. Also, we get also the basic principle that the compression capacity is always lower than the tension capacity. So we simply just only evaluate the compression element. And then to get the capacity of castellated steel beam, we calculate the axial compression capacity and then compare it with the internal axial force of castellated steel beam. The element we inspect is a flange, the compression flange, and then steel bar diameter 10 millimeter, 12 millimeter, 16 millimeter, and 19 millimeter, each on the model of castellated steel beam. On flange, we get axial capacity 186, and then steel bar diameter 10 millimeter, we get 16 kilonewton axial capacity. 12 millimeter, we get axial capacity of 25. 16 millimeter diameter of steel bar, we get axial capacity of 46, and then lastly 19 millimeters, we get axial capacity of 65. As shown in table, we get model CP1, or the moment capacity of castellated steel beam with diagonal stiffener diameter 10 millimeter, get the moment capacity of 42, and then CP2 with diagonal stiffeners 12 millimeter, we get moment capacity of 63, and then 16 millimeters on CP3, we get the moment capacity of 67. Okay, and CP4 we get also 67. The moment capacity of castellated steel beam stay in 67 Newton meter with either using 16 millimeter or 19 millimeter diameter. And then we got a pushover analysis to using a computer analysis program to execute pushover analysis. The result is a course of pushover. On CP1, we get a maximum force of 58 kilonewton. The other models, the output is like just this curve. For general, we get from pushover analysis, the moment capacity of CP1 is 44, CP2 62, CP3 56, and also CP4 similar to CP3, the moment capacity is 66 also. This is the comparison of thrust analysis and pushover analysis. They have a similar result between these two methods, and compared to the original white flank, the diagonal stiffener diameter size 12, 16, and 19 also have an increase. And then diagonal stiffener diameter size 10 have a decrement of moment capacity. The increment of moment capacity on CP2, CP3, and CP4 can be seen in this table on screen. In conclusion, the larger of diameter, the diameter size of the stiffener, it has the greater the moment capacity value of castellated steel beam. However, the increase is limited by the strength of the flank element in resisting compressive axial force. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for Pak Rusli. Since Pak Rusli is the last presenter in this session, so let's move on to the question and answer session. Let me check first on the chat book. We have several questions here. The first question is addressed to Pak Danang Cahyono. Referring to previous research that has been carried out in addition to the ease of work and economic and aesthetic factors, styrofoam tends to be more environmentally friendly compared to other materials because of its durability and resistance to environment. Time to use Pak Danang for answer the question from Dr. Ahmad Chandi.
Thank you. According referring to previous research that has been carried out in additive to the AC of work and economic and aesthetic factor, styrofoam tends to be more environmentally friendly compared to the material because of its durability and resistance to the environment. The following research study related to styrofoam material, the development of technology and the global market today make it essential to get styrofoam material on the market. Styrofoam material is lightweight, strong, and resistant to water. In Progo, styrofoam material is essential to work with when compared to the material seperti and analysis of the stability of the floating house platform using adjective material status that styrofoam is more effective and economic. Abstrasal. Styrofoam platform are more effective and efficient when compared to PVC platform. Adi. This is my answer. Thank you.
Thank you. The second question addressed to Mrs. Anikus Trini from Dr. Ahmad Chandi. Will you do a simple statistic test, for example, ANOVA, to see the differences among judgments? Of course, from the block graph, we can see the high different among different colors, but are they statistically different?
Thank you, Mr. Ahmad Sahri, Dr. Thank you for Dr. Ahmad Sahri. I will try to answer your question. I don't do eclipse test. This study is a preliminary study to conduct virtual research. What is the ideal molarity of the molarity variance? Thank you.
Next question is addressed to partly from Prof. Imawaydi. Why do you use combination of flat and bars to be different, not only partial?
Okay, thank you for Prof. Imam for the question. Actually, in my models, we use only just still pair. The plat is actually it is a web section of original wet flank section, still section. We only use reinforcement of using still pair. Why we use this reinforcement? We use it to actually counterfeit to avoid the mechanism of Pirendl. Pirendl is the occurrence of four plastic rings that happen simultaneously when it gives a low pressure load. Only that. Okay, thank you, Dr. Abdul Rahim.
Okay, thank you, Pak Robi, for your answer. I have one question for Ignatius here. I saw your presentation. Why did you make a measurement on day 36? Because it's normally to measure the compressive strength normally is made on day 28. Could you please explain why or the reason you make a measurement of compressive strength on day 36?
I'm sorry for Dr. Abdul Rahim. Here still Azan. So your voice is not clear for me. Maybe can type in chat.
Okay, Pak Damang, my question is from your presentation, you made the measurement of compressive strength on day 36. Could you please explain the reason why? Because normally the measurement of compressive strength of concrete is made on day 28.
28. Okay. I can try to explain why the measurement we try to compressive test from a specimen in 36 ya Pak? Sure?
Yes. Yes.
Okay. Okay. Yeah. Because we have a limit of study, but we can continue the the value of compressive strength based of the regression curve for the 50 days. We can get value for of compressive strength exceed the normally strength. This value we compare to other study too from two research previous the study. You can understand my explain, sir?
Okay. Okay, Pak. Thank you, Pak.
Yes.
Okay. My second question is addressed to Wani. Wani, from your presentation, you made several variation of addition sodium hydroxide. My question is why on day 7 and 28, the compressive strength lower than the first one. On the day 4, yeah, because I think it's interesting why the compressive strength even decrease after long run, after even on day 28. Why?
Oh, sorry. But I have a small increase compressive strength, but 10, 12, and 14 more decrease. So I choose the H small to input my study.
Okay.
I use.
Okay. Okay. Since we don't have any question in the chat box, so I think it's time to wrap the session. Thank you for all the presenters have presented their interesting study. Just remind for all the participants to fill in the attendance list, attendance form that has been shared from the committee. Okay, thank you very much for all participants and presenters have been joining the session. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Recording stopped.
Okay, everyone, we please you to have the whole prayer and lunch first. After prayer at 1, we will have the last session of ICCTA parallel session. Thank you. See you at 1 p.m. 1 p.m.